Okay, so now in this example, we will show that when you use the QR factorization, you will get the same condition number of the matrix R. Like in other words, like the condition number of the matrix A will be the same as the condition number of the matrix R. So how do we show that? So remember that the condition number of a matrix A is just given by the norm of the matrix A times the norm of A inverse. Okay. So and now we have the property that Q U will be the same as the norm of the vector U for all vector U in Rn. Okay. So how do we show that? So remember that QU, when you take the length of QU and you square it, then this one is just equal QU transpose QU. Okay. And because QU transpose can be written as QU transpose and Q transpose QU. Okay. And because in the QR factorization, Q is orthogonal matrix, so this one is identity. So then you have U transpose identity times U, which is just U transpose U, which is just the two norm of U square. Okay. So therefore, you have the norm of QU equal the norm of U. Okay. So therefore, QU, the norm of QU equal the norm of U. Okay, so now how do we show the condition number of A is the same as the condition number of the matrix R? So now if you go to the definition, so what is the norm of a matrix? The norm of matrix A will be the sum of the norm of AX over the norm of X. So for non-zero X, okay. And now this one, I will replace AX by QR because I have the QR factorization. So I have QR X divided by the norm of the vector X, and I sub it over on the vector X non-zero. But now because QRX, okay, so now if I label this one to be the vector U, then this is the same as the length of the vector Rx. Okay, because QU, the length of the norm of QU equals the same the norm of U. So I can put the norm of Rx here. And now divided by the vector X. And I sub over on the vector X non-zero. And by the definition, this one is nothing but the norm of the matrix R. Okay. And now you can do the same for A inverse. So A inverse, the norm, will be the same. You just replace A by A inverse here. Then it will be the same as the norm of R inverse. And now if you multiply the left here and the right here, then you have a condition number of the matrix A is the same as the condition number of the matrix R. Okay.